Hi everyone. In this video, we're going to go over graphing with multiple constraints. But before doing that, I would like to explain what constraints, the word constraints mean. Okay, what it means. It means we have some sort of limitations. We have some restrictions. So unlike what we did before when we graphed equations and or inequalities, just without any restrictions, right? We graphed them. If it was inequalities, we graphed them, we shaded the region, and that was it. We were done, right? And then we saw the part where the shaded areas overlap, if at all. Now we're going to have some sort of word problems, right? And we're going to have some limitations. So maybe we cannot have negative variables, right? Or negative valued variables. Maybe there are other constraints that we have, other limitations for our graphs based on the information that we're given. So that's what the word constraints means. Okay, it means again, it means limitations, it means restrictions. So we are going to graph, keeping in mind those restrictions. So with this being said, question number one says Barbara has $144 to spend on jewelry. Earrings cost $12 each, and necklaces cost $24 each. Barbara decides she needs more than 8 pieces of jewelry. So define the variables. So I'm going to say, to define the variables, I'm going to say let A or let X, let's call them, let X be the number of what earrings, and let Y be the number of necklaces. Okay, and you could have used the initials. You could have used E and N for earrings and necklaces, but I know quite a few of the students prefer using X's and Y's because we're just used to them. So this is defining the variables, right? That's the first part. Part B, it says, write a system of linear inequalities, right? Inequalities to model the scenario. So what is my system, right? What is the system? The system, first of all, we said here, if you recall, we said that she needs more than 8 pieces, right? That means the number of earrings plus the number of necklaces should be more than 8. So because of that constraint, right, that restriction, we want X plus Y to be greater than 8. Not greater or equal to, just strictly greater than 8, right? So this is, again, this is the number of earrings, right? And this is plus the number of necklaces, and that must be greater than 8. Now, the second constraint comes from, where does it come from? It comes from probably the price. So she has $144 to spend. That means she can spend 144 or less, right? And that to cover the cost of earrings and the cost of what? The cost of necklaces. So I'm going to put all this information together. For the second constraint, I'm going to say, remember earrings cost 12. So I'm going to say, I'm going to associate that with the variable X, which is earrings. So I'm going to say 12X, right, for earrings. And for the necklaces, it's 24 each. So it's 24Y. And that must be what? Less than or equal to 144, because that's how much she's got to spend. She can spend up to that point. Okay. Now notice that the first inequality, the one in blue, has a greater than sign. So this is going to be a dashed line, right? Or you can say next to it, normally we write dashed. And the one below it is got less than or equal to, so that's going to be a solid line, right? So keep that in mind. And by the way, here for the second inequality, remember where this is going to be the cost, right? This is the cost of earrings, right? It's the cost of earrings. And this is the cost of necklaces. And really, this is amount to spend, the 144, how much money she's got to spend. So this is my system of inequalities. Now, the third part, part C, is graph the system of inequalities, label the axes appropriately. So I'm going to label the x-axis here, let's say the number of earrings. And for the y-axis, I'm going to call that the number of necklaces. Okay, don't just put necklaces. We're looking for the number of necklaces, right? That's specifically what we're looking. Four necklaces. Okay. Now for the first inequality, the one in blue, we have x plus y is greater than 8. So as we saw in class, we can start by graphing this as if it wasn't equal, as if, right? And to do that, we can hide, for instance, x, which means make x equal to 0, and that's going to give me y equals to 8. So this will be 0, 8, which will be right here. Okay, and similarly, I can hide the y, which means make the y equal to 0, and that gives me x and 8. So x will be 8, so 8, 0, which is right here, 8 units on the x-axis. Okay, and I want to connect these two dots, but I want to connect them through what? A dashed line. So I can draw a line, and be careful when you're graphing, use a ruler, straight edge, and interrupt your line, right? This is dashed line. So that's the first inequality, but I need the values to be greater than 8. So I want to shade, if you recall, I want to shade above. Greater than 8 is above 8, right? This is above 8. And notice we're not going into the second quadrant, third quadrant, or fourth quadrant. And the reason is because the number of earrings cannot, for instance, be negative. So that is a constraint, right? That's a limitation. Unlike before, when we graphed without limitations, now we know we're only operating in the positive, right? Or non-negative, I should say, side of the number of earrings, and the positive or the non-negative side of what? The number of necklaces. So we're not using or utilizing quadrants 2, 3, and 4. So this is part of the constraints, part of the restrictions. Now, for the second inequality, the one in green, I want 12x plus 24y to be less than or equal to 144. So I can do pretty much the same, right? I can kind of cover the x. And if I do that, I'll get 24y and 144, which means y is going to be 6. So 0, 6. Remember, when you cover the x, that's like assuming x is 6. I mean, x is 0 in this case, right? So if I do that, I'll get y is 6, which is right here. And then similarly, if I cover dy, right? If I cover the y, I'll get 12x is 144, which means x is 12. So I'm going to go to here. And then when I'm connecting them, I need a solid line. We already talked about that. This is my solid line, and I want less than or equal to, so I'm shading below. So I'm shading below. So my shades are going to go below. But again, I shouldn't go here, right? Because there's not much going on here. So I'm shading below. And that could be also done temporarily, or I can use a different technique, like I can shade using, let's say, wavy lines, right? And then I can see where the wavy lines meet the blue lines, right? So the final answer for this is going to be where the two of these overlap, and that's going to be this region, right? It's going to be this, and of course, it doesn't go below the x-axis. So just be careful because we don't have negative values, right? So it's going to be here, it's going to be here, right? If I zoom in here, is going to be here. Right? Without passing the line, to be exact, right? So it's going to be in this region. As accurate as possible, it's fine. And then I can either keep the other stuff or the other lines or erase them. If I want to erase them, that's fine. I can go and erase each one of them. And now I can see that this is really the final answer, right? This is where the two inequalities overlap, the two meet. Now, in the part D, that was part C. Part D says use a complete sentence to describe the what the shaded region represents. So what does the shaded region represent? So you're going to say the shaded region, the shaded region represents What does it represent? It represents all possible solutions, which are what basically? So basically, they're all possible combinations of earrings and necklaces, right? All possible combos, right, or combinations of earrings and necklaces. But how so? Right? How so? What are the conditions? Right? Barbara can buy with what? With $144 while what? While getting what? While getting more than 8 total pieces. Because that's what she wanted, right? She wanted more than eight pieces, and she could only afford $144. So if you want that to happen, you want to basically find a point or any point here that would satisfy these two conditions, okay? Any point in this darker shaded region. Okay, so this is how constraints work. It's pretty simple process. So what I would do if I were you, I would, before looking at the explanation for number two, give it a shot on your own and see if you can follow what we did in number one and attempt number two. So pause the video, try it, and then play the video again. So now that we're back to this question number two, it says Tony has two jobs, delivering pizza for $10 an hour and tutoring for $15 an hour. And then he needs to earn at least, when they say at least here means greater than or equal to $180 per week, but he must work less than 15 hours per week. So he's got two things. We have the tutoring hours and we have what? The pizza delivering. So let's say, well, let me call them, you can call them X and Y, but let's change it up a little bit. We're going to say let, I should have said let before here. You should have let, right? I like to say let. Let, that what? P, the number of hours delivering pizza. And let what? Let T, the number of hours tutoring. Okay, that's defining the variables. Then write a system. So he wants to work less than 15. So we're going to say X plus Y is less than 15. This is the first inequality regarding the hours worked. The second inequality would have to do with the amount made, right? So one is going to be hours, one is going to be amount made. The amount made is going to be attached to the variables. So X is the, oh, we call them, I apologize, let's call them P plus T, right? Got carried away with the variables, P plus T. So now we're going to attach the money, right? We're going to make the money. So we're going to say 10P, that's for pizza delivering. And the tutoring is 15, so it's 15T. And we said he's going to make at least 180. So that's greater than or equal to 180. And maybe let me color code these. Let's color it blue. Okay. Okay. So these are the two inequalities, right? Now, keep in mind that the top inequality has less than, so it's a dashed line. The bottom inequality has a greater or equal to, there's an equal in it, so it's going to be a solid line. Okay. And let's put them together. Let's graph them for part C. So for part C, I'm going to start again for P plus T is 15. When you have that, you hide the P, you get T is 15, right? Then you hide the T, you get P is 15, P is 15, right? So those are your intercepts. So I'm going to go with 15, and let's label the axis, of course. This is going to be the number of hours delivering pizza, and this will be the number of hours tutoring, the y-axis. Okay. You could have swapped them. Someone may ask, yes, you could, right? Because here we didn't call them X and Y, right? So to play it safe, you can always call them X and Y, but it doesn't matter. Some may ask which one is X, which one is Y. It really doesn't matter. You decide that. In this context, you decide that. So now let's graph. P plus T is 15. We said if we cover the P, get T is 15. So there's going to be 15 right here. And then if you cover the T, get P is 15. So they're both, oops, 15. One to the right of that. So they're both 15s. And now you can connect the dots. Remember, you're doing a dashed line. So I'm going to make a solid line first, since I can do that digitally. Then interrupt the line. Okay. I'm going to dash it. Okay. And then I'm going to look at the second inequality, which is T 10P plus 15T is greater or equal to 180. So again, I can cover the E and I'll get 15T and 180. That means T is 12. So technically is 12 right here, up here on the T-axis. Remember, this would be here. Instead of column X and Y, right? This would be the P-axis. This will be the T-axis, right? It's very much like X and Y. So we said 12 and we did that. And then for the, if I cover T, I'll get 10P is 180. That means P is 18. So P is 18 is going to be here. And this is a solid line. So when connecting the dots, I'll get something like this, right? Now, you can, some like to graph each and then shade it right away. Some like to graph the two and then shade, or, do the shading. So let's go back to the shading, right? We have to shade. So for the shading portion, for the P plus T, which is the one in green, less than 15, that's going to be shaded below. So it's going to be shaded below, right? And I'm going to try my best not to go into the other quadrants. Just be careful here. And for the blue one, you want greater or equal to 180. So you want to shade above. Right? And where did the two, oops, above the blue. Where did the two meet? They meet right here in this shade, in this region here, where that's where green meets blue, right? So you have to be careful. So you can, or you can visually see that automatically and shade it right away, right? As a final answer, that's also acceptable. So I'm gonna really erase the other pieces here. And this here. And actually I'm gonna go, I know it's gonna be this area, so let me clean it up a little bit. So I'm gonna use a darker color and I will shade this region. Now remember, it actually does stop, right? Does stop on the y-axis or on the t-axis. Because again, there are constraints. And the constraints are that we don't get what? We don't get negative values. You cannot have a negative number of hours, right? Delivering pizzas or tutoring. Are we good with this? Okay. Do you see how accurate I'm trying to be here? So that I can present a good solution area. And by the way, there are infinitely many values, right, that live here. You zoom out, it's gonna look nice, right? So this is what this system is gonna look like, right? When you graph it. Graph, we label the axes, then finally write one example of a combination. So give me value or values that work. So I want to pick basically a point in this region. I can pick any point in this region, let's say a point here or a point here or a point here, right? I try to make it some corner point like here. This looks like a point that works. So this is 4, comma 10. 4 for the number of hours delivering pizzas, and 10 for the number of hours tutoring. So we can say, write one example, we can say 4, comma 10. And that's this satisfies. We use the word satisfies both inequalities. That means it works for both inequalities, right? So that means what? 4 hours of, remember, 4 is the x value, in this case, the p value, which is 4 hours of delivering pizza, and then what else? 10 hours of tutoring. Now, how do I know? How do I know if this really works? I can try it, right? Trying it doesn't. Trying it is not a proof, right? Trying it in the inequality, back in the inequality, is just to show it works. You can try. You can plug in 4 here and 10 here, and you can plug in 4 here and 10 here, and both inequalities should work. Like if you do 4 plus 10, that is less than 15, it checks. If you do 10 times 4, which is 40, plus 15 times 10, which is 150, 40 plus 150 is 190, that is greater than or equal to 180, right? You can quickly visually plug and check. And yes, this is one example that does work. All right. So hopefully this was helpful. Try number 3 on your own and see if you can come up. This would be your basically exit problem. You're doing this on your own initially, spend about 10 minutes. And if you feel you're struggling, check in with me and we can partner you up with somebody. Hopefully this was helpful, and good luck and thank you for watching.